channel again?
YouTube, I know, I should put a link at Aviation Maintenance Academy.
Yeah.
All right, so everybody knows this goes, every night I put this up on YouTube, so.
You got any more comments?
Like and put a comment below. All right, so we're talking about this triangle here, and again, in AC, we have inductive reactance, we have capacitive reactance. Those two cancel each other out if they're equal, but we're going to be setting up stuff that's not equal so that we get some sort of reactance. Either up here will represent a coil reactance, or if it goes this way, it's going to represent capacitive reactance. But we get a reactance and we have a resistance. And based upon the height of our inductive reactance and the length of our resistance, we are going to get a line over here, which is going to represent impedance, which is the total resistance, or what it acts like resistance, and that becomes a triangle. So we're going to, with our formulas, we're going to be able to find this leg here very easily. We'll be able to find resistance easily. I say easily, trust me on that. Which then, using a formula just like this, we're going to be able to find our impedance. And then once that's left, we're going to want to know what this angle is right there. So we got to figure out how to find that angle. And so to use that angle, we're going to be using those trigonomic functions, sine, cosine, tangent. But we're going to be using something called arc cosine, arc tangent, and arc whatever one I didn't just say. All right, so to look at this one more time, let's just say that we did this AC formula and we found out that we had 35. 35 is our value of reactance, all right? And we figured out our resistance was 65. We had 65, it's actually ohms. And so then we want to figure out, well, then what is the impedance going to be? And the impedance is always on the hypotenuse line. So again, how would I figure out my impedance, which is Z, Z. So what's the formula? A squared plus B squared equals C squared. All right, so we'll let A be 35 squared plus 65 squared equals C squared. So we should be able to figure that out real quick. 35x squared is 1225 plus 65 squared is 4225 equals C squared. So 4225 plus 1225 equals, you guys playing along out there? 5450 equals C squared. Now what do I do? Square root of both. So the square root of 5450, what would you come up with? 73.82. So the length of this is then 73.82. But now I want to figure this angle out. All right? So to figure that angle out, and this is one of the formulas. All right, so one of the things that I do, especially when we get into the electricity week, is I'm going to ask you as a class. So we come in to take the test on Friday. I'm going to say, class, before we get into this test, what formulas do you think you would want to know? And as a class, you're going to tell me formulas you would want to know, and I'm going to write them up on the board and leave them up on the board for the whole test. All right, I don't do that for everything, so don't count on it. But certain things you know, like milli and kilo, commit those to memory. But this is one of the things I would put up on the board for you. Remember, it's SOHCAHTOA, so which is to say that tangent, or -1, tan -1. So you should have that on your calculator and be able to see it. It's tan, cosine, and sine. Just look above there, and it says sine -1, tangent -1. So tan -1. Let me see, SOHCAHTOA. So tan cosine -1, and what am I? Sine. So that -1 is arc tangent, arc cosine, and arc sine equals, remember what tangent is? Tan? Okay, so it's opposite over adjacent. And cosine is
Opposite or hypotenuse.
Adjacent is, or so cosine is adjacent over hypotenuse. And sine is opposite over hypotenuse. So I want to figure out this angle right here. And so when I look at that, I actually have the hypotenuse. I've got, what is this then? What is this 65? Is it adjacent or opposite? Adjacent. I could use any one of these I want to. And so I'm just going to pick one. I'm going to say, let's use tangent. Now I could use any of these, and I'm going to get the same answer. I'm going to use this one. Why? I don't know. Just I'm going to pick something to go with it. I'm going to use tangent. So tangent, if I'm going to use tangent, it is tangent equals the opposite over adjacent. Well, what is the opposite from here? Okay. The opposite.
35.
Opposite, 35. So it's 35 over adjacent. What's my adjacent?
65.
65. Now I'll tell you why I like tangent. How did we get the hypotenuse? We found this and we found that, and then we did a math, and then we got the hypotenuse. So if I use the hypotenuse, it's relying on another level of potential mistake. By using tangent, I'm actually taking a step back and going, hey, I'm using some numbers I found earlier and hoping that the hypotenuse was right. All right, so 65 over 35. So it's tan minus 1 equals that. So these calculators work a little bit different. This one is, I go 35 divided by 65 equals, so I get tan minus 1 equals 538 is the number I get right there. What's that? So to get my answer on this calculator, it's going to be different on the blue one. But on this one, it is second tan, and I get an answer of 28.3 degrees. It doesn't say degrees.
You just took the 10 instead of 10 minus 1.
Say that again.
How'd you get the 28.3?
Okay, so how did I get 28.3? Which calculator you got?
Right.
Great calculator. Okay, so the formula is tan minus 1 equals 35 over 65. So I solved for 35 over 65. So it's just 35 divided by 65, and that is what?
Can't you just put it in your calculator?
Is what?
Are you talking about saying, I'm sorry,
Okay, everybody's with me now? Okay,
538, that's why
you got 538?
yeah.
You got that. Okay, now just hit the, now we want arctangent, not tangent, arctangent, which is tan minus 1. So you have to hit the second function key. So you have your 538, just hit second tangent, boom, spits out a number, 28.3.
If you're in degree.
What's that?
If you're in degree.
No, it just says 28.3. Now I'm telling you it's a degree. So my answer right here is, what is the phase angle? 28.3. I found the angle right here. This angle is 28.3. What is this angle? 90. Now you can figure out this angle.
Yes.
Just subtract 180, these two from 180, and you'd know that angle.
Do you have to put an adjustment before you do the tangent? Or can you do it?
It came out that way.
35.
35 divided by 65 equals 0.3538. It equals point. That's what it equals.
No, I know, but can you put it just in a calculator the first way and skip the second step altogether? Take out the middleman?
Maybe, I don't know. Yours, yes.
Okay.
Yes, yeah.
It will always be a right angle.
Yes,
Yeah.
it has to be because of the way that the impedance and the resistance are. They're at right angles to each other.
Does the tangent give you the ratio of the two sides? And the arc
It's not a ratio of the two sides. That's, I'm sorry, tangent does, yes.
Okay. An arctangent gives you the...
Gives me the angle based upon the length of the sides. So I kind of want to tell you what tangent was to tell you what arctangent is. So tangent is used to find the sides with a known angle. We need to find an angle based upon known sides. So we use tan minus 1 or arctangent. Okay, is everybody, you're good with that? Or how many people are not going to show up on tomorrow because I just scared you? All right, so, all right. Is this on the test tomorrow?
No.
Is probably not.
I'm just gonna cross that one out.
Okay.
Okay.
I don't think it is. But it's definitely going to be on a test in 2 weeks from now. But what we're going to almost do for that entire week is I'm going to explain AC over again. Then we're going to start small. We're going to figure out how to get one thing. Then we're going to figure out how to get another, then another, and another. And it's just it's a process of going through all of the steps, and then you end up doing this. So sadly enough, you can almost do all of it and get to the end and get the right answer. Go, yeah, I don't know what any of that meant, but I get you the right answer. Not too many things in my class work that way, but there you are. All right. So you ready for something? All right. Shake it off. Take a deep breath. Whew. All right. I do not know. Well, okay, it's as adult learners, it's important for you to know why it is you should know something. It's a known fact. It's a theory. I am sorry to tell you that I have no idea why you need to know binary numbers. Prince, why would we need to know binary numbers in aircraft? If Prince don't know, nobody knows. Okay. All right, binary number. So binary means two, right? So if a choice is binary, it's either, one or the other. So binary is based on 2 digits. So it's based on 2 digits. And technically, I don't know if one of them is a digit, but what are those 2 digits?
0, 1.
1 and 0. All right, so it's either what?
I know so it's the FAA who requires this, the binary, right? You're never going to use it as a account.
I don't know. Maybe you will. I just haven't. All right.
Yeah,
Yeah. All right. 1s and 0s. Now, it's funny, and I'm ashamed to admit this a little bit, but for the longest time, I had the hardest time with on-off buttons that look like that, and I was like, well,
Oh.
is
All
it?
makes sense now.
It doesn't it? It's a 1. Or the switches. You have a switch, rocker switch, and it has this.
Yeah.
Yeah.
And I'm like, I don't know. Is it O on or is it O off? Or it's 1 and 0, on and off. All right, so 1 is on and 0 is off. It's all based on and off. I'm like, oh, I get it now. All right, so
Go that way and turn it on.
so yeah, it's all based on the fact that a switch is either on or off. And it's based on powers of 2. That's base 2 binary, which powers of 2 go 1. 1 times 2 is 2. 2 times 2 is 4. Times 2 is 8. 16, 32, 64, 128. All right. This is the way I figure out how to do it. And my notes look terrible, so it's not going to probably work for me. Let me think. So we're going to be working with an 8-bit. So we just need 8 blocks. 1, 2, 3, 4, 5, 6, 7, 8. I guess I can get rid of 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 blocks. And to do all of the binary problems, just start here on this side. Start on the opposite side. What's first number?
1,
Next one?
2,
2 times 2 is?
4,
4 times 2 is? 8 times 2? 16 times 2? 32 times 2?
forgot that
What?
one.
1, 2, 4, 8, 16, 32, 64. All right? Just draw a grid like that. That's your tool.
Gotcha.
Okay, there's your tool. So binary number would look something like this. So here's a binary number. 00101111. Okay, there's your binary number. What is that binary number in regular number, in decimal number? Well, the way that works is you just take this and fill it in over here. 0, 0, 1, 0, 1, 1, 1. Oops, missed a 1, 1. 4 ones.
And you just add the ones up.
It's 5.
And then add them up. So what do you got? You have a 1 plus 7. This right here, this red means on. So my 1 is on, so I need a 1.
So 45.
The 2 is on, so I need a 2. 4 is on, so I need a 4. 8 is on, so I need an 8. And 32 is on, so I need a 32. Add those up.
$47.
47. So this is 47 in binary. Not so hard, was it?
So you only add the ones?
Only add the ons. Now you had to do that. I had to. You had to make the little chart right there. So again, if I said, I'll just make up in 1 0 1 0 1 1 0 1 1 2 3 4 5 6 7. Okay, I just made up that number. I just threw it out there. I don't know what it is. So I want to know what this number is. So it's 1 0 1 0 1 1 0 1. And add them up. Add 128 plus 32 plus 8 plus 4 plus 1. 128, 32, 8, 4, 1. And you tell me. 73?
173.
I was gonna say, it's got more than 173. Simple enough. The hard part for me is remembering you start with the right and work your way backwards when you do the 1. 1 goes to the right side. Instead of left to right, you go backwards when you're making this chart.
Is there a trick to turning, like, let's say 50 into binary? Just to make the chart?
Okay, so how do we go 50 back to binary?
Yeah.
Okay, so now we have to do it backwards. Okay, so, all right. Let's do one more. What if it's my binary number is it's just one that's the binary number given to you. That's it.
Okay.
Now what are you going to do?
Well, teaching.
Add those.
All zeros before?
All zeros before. So start on the left side.
Got it.
And it's 1, 1, 1, 1, 0, 0, 0, 0. So it's 8, 4, 2, and 1. So 8 to 15, right? So that's 15. 15 because you just add the zeros before. All right.
It's never after before.
Always before. All right. How about converting then a decimal to binary? All right. Convert. All right. So to do that, let's see. We'll start with the largest binary place. Start with largest binary place. I'm going to write this, but maybe it won't make sense. And subtract from the decimal number continue until all binary digits are determined. determined. Which is to say, I wrote that and I'm thinking, well, this is going to be easier just to show you. All right, so make my chart. 1, 2, 4, 8, 16, 32, 64, 128.
What's our number?
Let's convert and make it 233. 233 is my number. I got to convert that to binary. All right. So, can 128 go into that? Yes. So I'm going to give it that. So now I go 233 minus 128 equals. Thank you. 105. Right. Can I put a 2 here? Nope. So I go to 64. Can 64 go into 105? Yep. So I'll give it that. So I've got 105 minus 64 equals 41. Thank you. 32. Does 32 go into 41? Yep. So I'm going to give it 32. So 41 minus 32 equals 9. Thank you much. All right. So I've got 9 left. Can 16 go into 9? Nope. So I put a 0 right there. All right. Can 8 go in there? Okay, 8 does. So I'm going to do that. Now I'm going to go 9 minus 8 equals 1. So does 4 go in there? Nope. 2 go in there? Nope. 1? 1 does. So 233 as a binary is 1110101. Yeah.
So if the number is bigger than all those, just go to 256.
Okay, so let me ask you, what then is, what's the largest, this is 8-bit. This is what we call 8-bit because there's only 8 places. What's the largest 8-bit number we can do? 255 is correct. So if somebody said, if I give you number 256 and said, what is that binary? Go, it doesn't work that way. 8-bit, you got to go to 9-bit.
Many zeros.
Yeah, many zeros. So we're putting 2s in there. All right.
Is it the sum of all those things?
What's that?
It's the sum of all those numbers?
Yeah, the 255, whatever I told you was 255. It's a sum. It's 128 plus 64 plus 32 plus. Yeah.
How did we go from a decimal to 233? I'm lost there.
That's called a decimal number. 233 is a decimal number.
Oh, I thought there was gonna be like point two.
No. It's just it's got to be a whole number. Yeah.
So when you're the 233 into the 128, it says 233 subtract
Yep.
128, correct?
Yep.
So
Now I've got 105 left over. Right?
Why do you subtract that 128?
Okay, let's do.
It says, you said, does the 128 go into the 233?
Yeah, how do you figure that?
All right, let's do one more. So let's say we'll do something close to that. We'll do. Give me a number.
40.
Yeah.
We want to go up in a bit.
205. I don't know. I just made it. Okay, 205. Okay, so I want to go 205. Better yet, now we'll do 205. Okay, so I start with 205 and I look at this grid up here.
Wait, why don't you just do like, or 127, so that doesn't know the first one, you can show what doesn't know.
All right. Brett wants, I know, I was thinking about that, but then I thought, well, I could do that next. But all right, Brett wants to do this. So I want to do, Brett came up with a number and he has a good
I'm a
reason.
genius.
125. 125 is my number. Okay? 125 is my number and I want to convert to binary. Does 128 go into 125?
See, what does that mean?
Is how many 128s are there in 125?
Not a single one.
One.
Zero.
It can't go anywhere.
Yeah, go ahead.
Which is bigger, 125 or 128?
28.
So does 125 go into 128?
Oh, that's what I meant to say. Sorry, I think I said it backwards. Oh, there you go. That was my mistake. Okay, 120. Does 125 go into 128?
Yes.
Okay. Does it go to the? No. I actually, yeah, you got me screwed up. I did say it right. All right. Does 128 go into 125?
No.
It does not. So that has to be a 0.
All right.
Has to be a 0. All right. Does 64 go into 125?
Yes.
Yes, I need one of those. So I'm gonna go 125 minus 64 equals.
When you say that, to
61.
me, I want to think that it goes in there evenly, but it's just there's space for the 64 and the 125.
Right. It's like, and let me speak your language here. It's like I have a 125 gallon fuel tank and 128 gallons. Should I
Yeah.
pour it in there?
No.
Okay, so I'll put a 0.
Let's give it a shot.
Can I put 64 gallons in there?
Yes.
All right, so I'll put a 1.
Okay, that
How many more gallons do I have left? I got to fill.
61.
I got 61 gallons. All right, so so I have 61. So does the 32 go in there?
Yeah.
Yeah. Okay. So now I'm going to have 61 minus 32 equals
29.
29. Okay, so I'm going to use a 16 then. So 29 minus 16 equals 13. So I'll put the 8 in there. 13 minus 8 equals 9. Oh, thanks. 5. Okay, so I can use the 4. 4. And then that's obviously going to be 0 and then 1. And then we have taken all the fuel and filled up all of our little fuel buckets. So.
Okay, that would make sense.
Okay.
You don't have to lie, Ted.
All
I
right.
was lost before, but now I got one. And we got a nice chart.
Any questions then?
Yeah.
That's on the
Not
test
speed
log?
fuel. That's the